And welcome back, and it is the 29th of March, the higher plus 5 a day, almost end of the month, and let's go to the first question. Right, what do we have? Now, I was about to say something different, but I realised that there's a word here which is the word estimate. So I'm going to say that to mean this is not a calculator question, so it's not just banging in your calculator, but it's a maths trigger word or a maths command word, let's say in a non-calculator paper, for using the nearest relevant significant figure or figures. And what I mean by that is, so typically estimate means round to one sig fig, but here I'll acknowledge that what's happening is I'm taking 50, the half, or the, so if I think about this as a minus 1 times 3 times a half, the half part means square root, the minus means 1 over, and the 3 means cubed. So if I put all these things together, well, I can't do that because I don't know what the square root of 50 is. The estimate, as I say, I believe is a trigger word here, or at least the way the question is probably constructed, or the way I would interpret it, especially on a non-calculator paper, to pick the nearest thing I do know how to square root. And that's going to be 49. So in other words, I'm going to estimate my number by doing the square root of 49, taking the reciprocal of that, and then doing that to the power of 3. Well, the square root of 49 is 7. 1 over that is 7. 1 over 7 to the power of 3. You may not know your 7 to the power of 3, but it's a good thing just to be aware of, is 1 over 343. Now, just for reference, and this obviously won't be part of the exam, but if I get my calculator out, because it's here next to me, so 1 divided by 343 is about 0.0029, so 0029, and the actual answer, again rounded, is going to be 50 to the power of minus 1.5, which is 0.00283, so 0.00283. So you can see my estimate is very good. The point is, getting back to the point of the question, the word estimate means pick a suitable number that will give me a good approximation, which is what I've done. Question done. Next question. The first 5 terms of a quadratic sequence. I've had quite a few quadratic sequences on the further maths one, but this is a higher plus, isn't it? So let's do this the way that I always do it. And then it says, just to make it different, work out the difference between the second and 20th. Okay, now because it's not linear, there's not an easy way of doing this without actually just working out the nth term. So I'm going to need the nth term. Now, if this is the first time you see me do one of these, I do it slightly different to how others may do it. So let me walk through. So first of all, what's the difference? So 4 to 10 is 6. 10 to 18 is going to give me 8. I don't actually need to do any more, but I'll do one more just to double check. So 18 to 28 is 10, which means the difference of my differences, otherwise known as my second difference, is going to be 2. I then think about the general nth term of a quadratic sequence, which is which is an squared plus bn plus c. In other words, un is equal to that. And this term here is always a second difference over 2, and 2 over 2 is equal to 1. Okay, great. So now I know, so let's write this down again. So 4, 10, 18, 28. I don't need any more terms than that. Now I know, and how do I know this? It's because someone has done some math somewhere else and they've worked out that this method works, which I know is not a great way of saying it, but there is a proof, which I won't go into here. Now I know that this number here is 1. I'm going to take 1 lot of n squared. So this is my first term, this is my second term, this is my third term, this is my fourth term. So 1 squared is 1 times 1 is 1. 2 squared is 4 times 1 is 4. 3 squared is 9 times 1 is 9. 4 squared is 16 times 1 is 16. And that's because I know the quadratic part. I know the n squared part. So if I take away the quadratic part, that leaves me 3, 6, 9, and 12, which I recognise as a linear sequence which has general term 3n, which means my combined nth term is going to be, now I'm going to put this over here onto so I've got space. So therefore un is going to be equal to n squared, where you'll remember the n came from halving this number here, plus 3n, which is basically whatever this linear sequence is here. And that's my nth term. That's not the question though. The question says, or the question wants me to use that to work out u20 and u10. So if I get u20, I'm going to put 20 into here, so 20 squared. Let's write it out. So 20 squared plus 3 times 20. Well, 20 squared is 400, and 3 times 20 is 60, so that's 460. And 10 squared, or put in 10, so that's 10 squared plus 3 times 10. 3 times 10. And 10 squared is 100, 3 times 10 is 30, so that gives me 130. Now, I have to say, last couple of videos, I've missed the odd thing here and there because I'm not following my own rule of checking the question. So I'm now going to go back, read the question. So it says, work out the difference between the 10th and the 20th terms. So I've worked out the 10th, I've worked out the 20th, which means the difference, which is my answer, is going to be 330. And that's my answer for that question. Nice question. Next one. Okay, so obviously a bit of 3D trig or 3D Pythagoras. So I've got a square-based pyramid. Seems important, which means, by the way, that that's 2 centimetres and that's 2 centimetres. F is the midpoint of CD. I've just kind of used that already. M is the midpoint on the base directly below vertex E, which just means it's symmetrical, and it means I can therefore drop a perpendicular straight down to the middle of the square at the bottom. And that means then I'll work out E to M. Well, the way to do these questions is to think about what I'm trying to do. So I'm trying to think about a triangle where I've got E and I've got M, so that's the length I want. And I know this is 7, so it tells me the long diagonal is 7. And it feels like I need something else. I'm going to need C. In other words, I'm going to need from A to C and then going to halve it. So I'm going to need a triangle to help me with the first triangle. So I'm going to set up the triangle ACD. Now ACD is on the floor, and I know the side length is 4, and I know this side length is 4 here, which means this length here is going to be 4 squared plus 4 squared square rooted, Pythagoras, because it's a right angle triangle. 4 squared plus 4 squared is 32. Square root of 32 is going to give me 4 root 2, which means I know my hypotenuse is going to be 4 root 2. Now, that is all the way from A to C. But M to C must, if it's symmetrical, be halfway from M to C or A to M. So in other words, this length here must be 2 root 2. And crucially, for the triangle that I care about, I've got E to C. I've worked out what M to C is, which means using Pythagoras, I can therefore work out the thing I want, which is the length E to M. So E to M, using Pythagoras, is going to be 7 squared minus, or 2 root 2 is the square root of 8. So 2 root 2 squared is 8. So 7 squared minus 8. 49 minus 8 is 41. So that's going to be the square root of 41. Now, quick aside, didn't do this intentionally, but it's quite a good time to do it. 2 things. 1, note the units. It will probably give you the units in the exam, but I'd make sure I write the units. And secondly, because I've done my working above other working, just make it really clear in the exam that is your answer. So the examiner is required to mark what you present as your answer. You just have to make sure your answer is clear. Normally, your answer is the last thing that you write, so just be careful. Anyway, question done. Next question. Work out the angle between the line EF and the plane ABCD. Now in this one, I'm going to delete some of the stuff we've got so I can redraw this. So on this one, I'm going to be considering this triangle here, because I've worked out E to M, over to here, M to F, and then the triangle down here, which will give me this angle that I want. So I'm going to reproduce this triangle down here. So I've got E to M. You'll remember I know what that is because I've just worked that out. That's the square root of 41. I've got M to F, which is 2. Well, how do I know it's 2? Because that there is the same as half of this here, in other words, A to D. So I know, therefore, that must be 2. And then I'm going to join that line up, so that's to F. And this is the angle that I want here. I've got 2 sides. I've got 2 and root 41, which means I can use trigonometry, opposite, adjacent. So it's going to be tan minus 1 of opposite, root 41, over adjacent, which is 2. Calculator out. And that gives me 72.654 degrees. Now, checking, does it want any decimal places? It doesn't, so I'm just going to call that 72.7, is it? So 72.7 degrees. And question done. Next question. All right, what do we have? So find where the tangent to the circle gives me a circle equation at the point 412. Right, you don't have to. Quick sketch here is going to be helpful just to confirm things in your mind. So I've got a circle, centre 0, 0, as they always will be at GCSE. I've got the point 4 minus 12, which I don't know if it's exact, it's about there. And I need to find out where it meets the x-axis. So the tangent is going to be a line that goes all the way over here. So it's going to be quite far over. So I'm expecting quite a big number. And I need to find out what this value is here. Right, typical approach. I need to work out the equation of my tangent. And then I need to find out where that meets the axis. I'm going to start by working out the gradient to the radius. Well, that's going to be down 12 and across 4. In other words, this line here. I'm then going to note that my tangent must be the negative reciprocal. So my tangent is 4 over 12, which is the same as 1 over 3, which means the equation of my tangent is going to be y equals a third x plus c, where I know the point 4 minus 12. So in other words, y, which is minus 12, is equal to a third x, which is 4, plus c, which means that c equals minus 12 minus 4 over 3. So minus 12 minus 4 over 3 on my calculator, which is going to be minus 40 over 3. Not a great number, but I'm happy with that. So minus 40 over 3. And just to do it for completeness, I'm going to write that down. So therefore y equals a third x minus 40 over 3. But remember, that's the line of the tangent. I want to know where it meets the x-axis. In other words, I care about where y equals 0. And where y equals 0, a third x is equal to 40 over 3. In other words, it must be the case that x is equal to 40. Multiply both sides by 3, leaves me a 40 behind. And just for completeness, I'm going to write the coordinate of that as 40, 0. Question and today done. It's my usual comment. A really good mix of questions today. Really like that first question. Probably a non-calculator question. Quadratic sequences, good to see those back again. 3D trig, everyone dislikes 3D trig, so definitely practice that. And a nice, clever twist on a circles question at the end. Let me know how you did. As ever, do like, subscribe, and I'll see you for the next one. Thanks all.